This is x-axis, this will become y-axis. We projected with velocity u. The path of the obliquely projected body is like this. It is like parabola. See, what about at the highest point? At the highest point, at the highest point. So what we want to calculate the highest point? The highest point means the maximum height. What is the potential energy? What is the potential energy? So if we want to calculate potential energy, mgh, mgh. So h is here maximum height, mg. H maximum, h max value u square sin square theta by 2g. U square sin square theta by 2g. 2g gets cancelled. Half mu square sin square theta. See, this is potential energy of a obliquely projected body at the highest point. At this point, at this point, the what is the potential energy? That is equal to half mu square sin square theta. See what what I did here, simply already we know potential energy is equal to mgh. So I substitute h max here. This is the height, h max. This I substitute h max formula. Finally I got half mu square sin square theta. So this is at the highest point. What is the potential energy? Just you copy it. Just we want to calculate one more potential energy at the highest point. Already we calculated. So if you want to calculate kinetic energy, what is the kinetic energy at the highest point? One more. Okay. See, simply at the highest point, potential energy equal to mg h max. That is equal to mg into u square sin square theta by 2g. Gg gets cancelled, half m u square sin square theta. So this is potential energy at the highest point. So one more, kinetic energy at the highest point. Kinetic energy at the highest point. See, this is the path of the body, x-axis, y-axis. So this is the highest point. At the highest point, what is the kinetic energy? Generally, we have the formula half m v square. Half m v square. So here, what is the velocity we have here? Vx, Vy and Vx. Vy equal 0, only we have the Vx component. So just substitute here half m Vx square. Half m Vx is nothing but u cos theta whole square. Half m u square cos square theta, that is equal to k. Half m u square cos square theta. See how I am calculating here. Simply I am using general formula what we have in mechanics. Just I used kinetic energy equal to half m vx square. So half v square it is there, but at the highest point, is it not visible clearly? Now it is. Now it is okay. Okay. See, just I'm calculating here. I'm repeating. I think it is not visible to you. So I'm repeating. Y-axis, x-axis, y-axis. I projected with u velocity. The path of the projected obliquely projected body like this. at the highest point. This is highest point. See, we want to calculate the highest point. What is the potential energy? What is the kinetic energy? What is the potential energy? What is the kinetic energy? So at the highest point. See, potential energy formula generally we have mgh max. mgh max. Already yesterday we calculated maximum height formula mg into u square sine square theta by 2g. That is equal to half m u square sine square theta. So this is the potential energy formula. We calculate the maximum height at the maximum height. See, generally we have the potential energy formula mgh. So this maximum height is h max. So just I substitute there. So what about kinetic energy? Generally we have kinetic energy formula of m v square. So at maximum height it has only vx component. There is no vy component, that is equal to 0. What is vx? U cos theta, half m u cos theta whole square. Half m u cos theta whole square. Half m u square cos square theta. So this is kinetic energy. So just you copy it at the highest point. What is the potential energy? Generally we have the potential energy formula mg h max. Just substitute h max u square sin square theta by 2g. Then what about kinetic energy? Half m v square, but it is there at the highest point. We have only vx component. There is no vy component. Just substitute vx component, that is u cos theta here. Then you will get half m u square cos square theta. Then add these two things: potential energy, kinetic energy at total energy at the highest point. What is the total energy at the highest point? That is equal to half m u square sin square theta, half m u square cos square theta. So sin square theta plus cos square theta equal to 1. Finally you got total energy equal to half m u square. Half m u square. So just I discussed here, what I discussed here, at the highest point, what is the potential energy, what is the kinetic energy, what about total energy? Is it clear or not? Just I explained only one concept here. What is the energy at the highest point? How much energy it has at the highest point, that is potential energy. How much kinetic energy it is there? Just substitute this formula: total energy equal to half m u square. Then this is equal to constant. At the highest point, total energy is constant. Okay. So you just copy it. Then ratio of kinetic energy and potential energy. See, we calculated here. What we calculated? Potential energy, kinetic energy we calculated. So what is the ratio of potential to kinetic energy? One more. This is A, this is B. Now I am discussing C. Ratio to potential energy, ratio of potential energy to kinetic energy. Potential energy equal to half m u square sin square theta by half m u square cos square theta. Half m u square sin square theta by half m cos square theta. That is equal to tan square theta. That is equal to potential energy by kinetic energy. So this is one more formula. C point. At the highest point, it has potential energy half m u square sin square theta, kinetic energy equal to half m u square cos square theta. See, I am discussing about the ratio to potential energy to kinetic energy at the highest point. ETB by EP energy, potential energy by kinetic, that is equal to tan square theta. Write this point also. Okay. Then I am discussing one more D point regarding to this one. Here, if this is also right D point, if capital T is the time of flight, is the time of flight, capital T is the time of flight, then maximum height equal to maximum height equal to. So what is the maximum height? If capital T is the time of flight, maximum height equal to, generally we have the maximum height formula u square sin square theta by 2g. So in the question, what is the question we have here? If capital T is the time of flight, what about maximum height in terms of time of flight? That is the question. So we have capital T equal to 2u sin theta by g, 2u sin theta by g. So from this, just substitute u equal to t by 2 into g by sin theta. T by 2 into g, t by 2 into g by sin theta. Just substitute here. See, from this, capital T equal to 2u sin theta by g. What is our question actually? If capital T is the time of flight, what about maximum height in terms of time of flight? So already we have got the time of flight, total time of flight equal to u sin theta by g. From this equation, just you write for u, then substitute here. T by 2 into g by sin theta whole square sin square theta by 2g. Is it t square by 4 g square by sin square theta by 2g. Sin square gets cancelled, g gets cancelled. So what we have, 1 by 8 gt square, 1 by 8 gt square, that is equal to h max. Just what I did here, simply I converted maximum height formula in terms of time of flight. In terms of time of, if we know time of flight, we can calculate maximum height. Just I change the formula. That is the conversion between two formulas. So initially we have, what is the maximum height formula? U square sin square theta by 2g. That is t equal to u sin theta by g. We can write u equal to t by 2 g by sin theta. Just substitute here. You will get maximum height in terms of maximum height formula in terms of time of flight. Just copy it. Then one more problem. This is D. Just conversion only I am discussing here. Conversion between maximum height, time of flight, like that. So one more. E, the relation between theta, projected angle, projection angle, range and maximum height. Relation between theta, range and maximum height. What is the relation between these three? You just think it, I will explain. Do you know? Just think it. So already we have for this one solution h max equal to u square sine square theta by g, u square sine square theta by 2g, h max. Then what about range? U square sine 2 theta by g, here sine 2 theta. H max equal to u square sine square theta by 2g, range equal to u square sine 2 theta by g. So what we have to calculate actually the relation between theta, r and h max. Already we calculate range of the projected body, maximum height acquired by the projected body, the theta is the projection angle. So for this, take ratio, this is 1 h max h max by r. So h max equal to u square sine square theta by 2g, r equal to g by u square sine 2 theta, sine 2 theta. So what about here? This is the first term, this is the reciprocal of this one, u square g by g. So top we have in numerator sine square theta, in denominator 2 sine 2 theta, 2 sine 2 theta. So that is equal to sine square theta by sine 2 theta is nothing but 2 sine theta cos theta, 2 sine theta cos theta. Then sine theta gets cancelled. You will get sine theta by 2 to the 4 cos theta, that is equal to h max by r, h max by r. So we can write sine theta by cos theta tan theta by 4, tan theta by 4. So we can write tan theta equal to 4 h max by r, tan theta equal to 4 h max by r. So this is one more relation between theta, r and h max. Just copy it, this one. This is also one important formula, tan theta equal to 4 h maximum by r. Tan theta is nothing but projection angle, projection angle. Okay, then I will discuss one more f concept here. What is f concept here? F. So what is f? The projected in case of complementary angles, complementary angles. So complementary angles, do you know complementary angles? What are the complementary angles? If the sum of two angles equal to theta 1 plus theta 2 equal to 90 degree, then we can say these two are complementary angles. That means if one angle is theta, then one more angle is 90 minus theta. These two angles are complementary angles. So if we projected with theta, see one more, if we projected 90 minus theta, so in the first case the range is r1, in second case the range is r2. See, what is the first case? The projected body, the projection angle is theta. In second case, the projection angle is 90 minus theta. These two angles are complementary angles. In first case, if you projected a body with theta, the range is R1. In second case, if you projected 90 minus theta, the range is R2. What are the relation? What is the relation between R1 and R2? That is the question here. So for that one, we already have range equal to u square sine 2 theta by g. U square sine 2 theta by g. So if for example R1 equal to u square sine 2 theta by g, R2 equal to u square sine 90 minus theta by next. So we can write this one u square sine 180 minus 2 theta by g, u square sine 2 theta by g. So see, observe these two relations. Observe these two relations. What you are getting? See, this one equal to R1 equal to u square sine 2 theta by g. This is also u square sine 2 theta by g. So that means if the angles are complementary angles, if the body is projected with complementary angles, in two cases the ranges are also equal to R1 equal to R2. This is also one more concept, one more point, that is, if we projected with theta, it acquired the range is R1. If we projected one more complementary angle, if the range is R2, what is the relation between R1 and R2? So that is equal to R1 equal to R2. This is one more important point. Just copy it. Okay. Then one more regarding to complementary angles. See, what are the complementary angles? If the sum of two angles equal to 90 degree, then those two angles are complementary angles. That is equal to, for example, 30 and 60. 30 plus 60 is equal to 90. So the 30 degree and 60 degrees are complementary angles. Other like that, 40 and 50, 20 and 70. Okay, I am discussing one more regarding complementary angles. That is Z if H1 H2. If H1 H2 are maximum heights, H1 and H2 are maximum heights, then H1 plus H2 equal to u square by 2g. H1 plus H2 equal to u square by 2g. So this relation we have to derive. So we have, if H1 and H2 are two complementary projected maximum heights. See, the first body is the H1 is nothing but the body is projected with theta angle. H2, the maximum height is acquired by the body, that is projected 90 minus theta. So just first you write generally H max equal to u square sine square theta by g. So if H1 u square sine square theta by g, u square sine square theta by 2g. If H2, what about H2? U square sine square 90 minus theta by 2g. U square sine 90 minus theta cos theta, sine 90 minus theta equal to cos theta. Just substitute here cos square theta by 2g. H1 u square sine square theta by 2g, H2 u square cos square theta by 2g. So what about H1 plus H2? If you know little bit trigonometric functions, if you have some knowledge about trigonometric function, you can do these all things very easily. U square sine square theta by 2g, u square cos square theta by 2g. So sin square theta plus cos square theta equal to 1. So that is equal to u square by 2g. h1 plus u square by 2g. So these concepts I explained today. Tomorrow also I will discuss about oblique projected body, some situations, some examples. I discussed up to here G points. For example, 7 or 8 points I explained. This also you just copy it. So what is the question is, if h1 and h2 are maximum height acquired by complementary angles projected bodies, then what about h1 plus h2? That is equal to u square by 2g. It's simple this concept. Just copy it and read it. I will discuss tomorrow.